Okay, we're going to go over Chapter 2, Chemistry of Life, Vocabulary, PowerPoint. This is going to be the vocab that you need to know for your test on Monday, September 14th. The first word is atom. It's the smallest unit of an element that maintains the properties of that element. We cannot split an atom down into its parts by standard nature means, normal means. Okay, because when you do split an atom, it does create things like bombs, big kabooms. Okay, but an atom is the smallest unit of an element that maintains a property of matter. A proton is a positively charged particle found in the nucleus of an atom. So here's a picture of an atom. This center part right here is the nucleus. We have got protons and we've got neutrons. Protons are the positive charges. Okay, the number of protons determines the atomic number of an element. Hydrogen has one proton, one neutron, one electron. Because it has one proton, it has an atomic number of 1. Neutrons are found in the nucleus with the protons and have no charge. They are neutral. Electrons are found floating around the outside of the nucleus. In the electron cloud, electrons have negative charges. An ion is an atom, radical, or molecule that has gained or lost one or more electrons and has a negative or positive charge. In our class, we're going to focus on the atom. So an ion is an atom that has lost an electron. So if you lose an electron, you lose the negative energy, you're going to be positive. It's formed a positive ion. If you gain an electron, gain negative energy, you're going to be a negative atom or a negative ion at that point. So ion, gain or lose electrons. An element is a substance that cannot be separated or broken down into simpler substances by chemical means. These are meaning things like in a normal environment, we cannot break down elements into simpler substances, into their atoms. Okay? We can in labs, but it is difficult. It does take a lot of work. Okay? A molecule is the smallest unit of a substance that keeps all the physical and chemical properties of that substance. The molecule that we're going to talk about in class the most are going to be water molecules. Compounds are a substance made up of atoms of 2 or more different elements joined by chemical means. Now, compounds are molecules or can be molecules, except where a molecule can be like water, you have hydrogen and oxygen, or it could be like oxygen gas, where it's just O2. It's the same element. Compound, it has to have 2 or more different elements. That's what makes it a compound. A bond is a strong force of attraction holding atoms together in a molecule, resulting from the sharing or transfer of electrons. The strongest bond that we're going to talk about are covalent bonds. They involve the sharing of electrons. So 2 or more atoms are sharing electrons, which means they are physically holding on to each other. An ionic bond is where ions are formed, where one atom gains an electron and is negative, or one atom gives away an electron and is positive. In that case, the positive and the negative, just like with magnets, attract to each other. Hydrogen bonds are weak bonds involving the sharing of an electron with a hydrogen atom. We're going to mainly talk about this in the form of DNA molecules being held together by hydrogen bonds. When there's a lot of them, then yeah, they're really strong, but individually they're weak. Hydrogen bonds are also what holds different molecules of water together. Polarity is a compound whose molecules have an unequal distribution of electrical charge, so that one part of the molecule is positive and the other part is negative. Water is a polar molecule. The end with the oxygen has more of a negative charge. The end with the hydrogens have more of a positive charge. Because the molecule has a positive end and a negative end, it's like a magnet. Okay? Different ionic molecules are attracted to each other. Different polar molecules are attracted to each other. Cohesion is the binding together of like molecules or similar molecules. Water molecules are attracted to each other. Okay? When you see raindrops on a car windshield, okay, the droplets are actually attracting. You can actually see them pulling towards each other. There's something called surface tension. So on very still water, okay, The molecules will attract so close together that little bugs like water striders can actually walk on the water. So cohesion, similar or like molecules, where adhesion is dissimilar or unlike molecules. Uh, think about if you spill Kool-Aid, you're going to put a paper towel. That paper towel absorbs up that liquid. That absorption is capillary action. The two different molecules are attracted to each other and binding together. Adhesion. Two different molecules. Two dissimilar molecules. A solution is a mixture in which the minor component, or the solute, is uniformly distributed within the major component, the solvent. In this example here, we're going to pretend that this is sugar being dropped into water. Okay? So here we have a glass of water. The water itself is the solvent. The sugar that's being dropped into the water, that's the solute. Okay, in this case, when it means uniformly distributed, the sugar dissolves into the water. Eventually, it disappears from the naked eye, so you don't see it, but it doesn't just vanish. It's still there. It's just now distributed throughout the water. If you were to taste it, you'd see that it was really sweet water. Aqueous just means water-based. pH is a value used to express the acidity of a solution. You've talked about pH since you were in elementary school, whether something is an acid or a base. Now we're going to make it a little bit more advanced. An acid is any compound that increases the number of hydronium ions when dissolved in water. So when we're talking about pH, we're talking about how something reacts with water. And with an acid, when you add it to water, the water molecule splits apart and you get a lot of these random H plus or hydronium ions floating around. An acid has a pH of less than 7. Okay? So the closer you get to 0, the more acidic something is. A base is any compound that increases the number of hydroxide ions when dissolved in water. So again, it's in relation to water. So when we add a base to water, you get a lot of OH negatives floating around. It's a pH of more than 7. Things like bleach and milk and antacids are bases. Anything that is neutral has a pH of right around 7. It can't vary too far from 7. Sometimes around a 6.7, 6.8 to about a 7.3, 7.4 is considered neutral. Okay. If you have heartburn, okay, that's your stomach acid rising into the esophagus, you take an antacid, okay, Tums. Okay, that Tums will neutralize the acid. And neutralize means it's bringing that pH back down to about, or back up to about the 7. A chemical reaction is a process in which the composition or structure of a chemical is changed to form another substance. Okay, chemical reactions would be if you have 2 hydrogens and an oxygen, you get water. Another one, photosynthesis. You have sunlight, water, and carbon dioxide, which is going to give you glucose and oxygen. So when we have a chemical reaction, what we start with is called the reactants. Okay, so the reactants are going to react to make the products. So the reactants in photosynthesis, we start with sunlight, water, and carbon dioxide. Those are our reactants. They make the products, the glucose and oxygen. So the products are what gets formed as a result of the chemical reaction. They're what we end with. Okay? So you need to study these terms for your test on Monday, September 14th.